The plane was sinking, deeper and deeper.
In the heart of one of Asia's busiest cities, rescuers rush to pull air crash survivors to safety.
Nothing wrong with this actuator.
Taiwan's Aviation Safety Council confronts some urgent questions about TransAsia Flight 235.
What were the flight crew doing? Were there engineering issues involved in this event? How on earth did it end up in this situation?
Take a look at this.
A video surfaces that makes the disaster in Taipei notorious worldwide.
It's quite harrowing because you're seeing the final moments of a tragic event unfolding before your eyes.
What was happening on that plane?
Taipei, capital city of Taiwan. Near its center, amid soaring towers, lies Songshan Airport. The next plane scheduled for departure this morning is TransAsia Flight 235. The TransAsia cabin crew is waiting for a last-minute addition to the passenger list.
Welcome aboard. Row 19D, midway down aisle seat.
Dr. Liu Chaohui has made it.
It just so happened that particular flight had a few open seats. I was supposed to be on the later flight, but I decided to get on the earlier one.
Yeah, is this me?
Ladies and gentlemen, make sure your seat backs and tray tables are in their full upright positions. Ensure your seat belt is securely fastened.
There are 3 highly trained pilots in the cockpit. The first officer is Liu Zichung. He has almost 7,000 hours of flight time.
Oil pressure?
Check.
The captain, Leo Chiensung, is a former military pilot. There's also a third pilot who's an observer on today's flight.
45 starter off.
Start lights off.
TransAsia 235 is a commuter flight from Taipei to the Taiwanese island of Kinmen, just off the coast of mainland China. Scheduled flight time is approximately 1 hour.
Would you like a paper?
Oh, thank you.
Dr. Liu Chaohui is returning home to Kinmen, where he runs a medical practice.
I usually took TransAsia because their service was quite good. When I'd get on the plane, I'd like to grab a paper and catch up on the day's events.
The cabin's ready, sir.
Okay, roger, thanks.
Songshan ground, TransAsia 235.
Request taxi.
TransAsia 235, runway 10.
Taxi via Whiskey.
Okay, whiskey to 10.
The ATR 72600 is the latest, most advanced version of the European commuter plane. Its Pratt & Whitney turboprop engines are extremely powerful and fuel efficient.
It's a very popular aircraft, particularly because it has attractive operating economics. It's commonly used in short-haul regional airline operations.
The pilot's digital displays create what's known as a glass cockpit.
When people refer to a glass cockpit aircraft, they're referring to not only the displays, but what often we're talking about is an advanced technology aircraft with sophisticated automation capabilities.
The electronic checklists switch automatically. Once you complete certain parts, it'll switch forward.
The first officer briefs his colleague on the cockpit's technology. Hong Ping Chung is an experienced pilot who's learning this computerized system.
Can you do it manually?
Well, you can, but when starting the engine, for example, it'll go to the next page once you close the bleed valves.
Songshan Airport sees 6 million passengers a year. For air traffic controllers, that means handling about 100 flights a day.
TransAsia 235, runway 10, wind 100 degree, 9 knots, cleared for takeoff.
Okay, cleared for takeoff.
Cabin crew, prepare for takeoff.
Have a great flight.
Thank you. Enjoy your flight.
Just before 11 in the morning, Flight 235 gets rolling.
Engine instrument check, normal.
V1.
V1,
Rotate.
The captain engages the autopilot and sets his desired airspeed and altitude.
As soon as the aircraft is taken off, they're going through a series of checklist items.
Gear up.
gear up.
I know they've got a particular climb profile, and they're executing the after takeoff checks and the initial climb checks to make sure that all the systems are performing as required.
Flight 235 climbs out over metropolitan Taipei, a densely packed city of more than 7 million people. Seconds later, the master warning sounds.
The master warning is indicative of an emergency situation requiring an immediate response.
TransAsia 235 has lost an engine. The captain disengages the autopilot.
I have control.
You have control.
In the cabin, engine noise suddenly drops. The pilots need to get their plane back on the ground.
Heading mode.
The captain wants a heading back to the airport.
We're below 2,500 feet. Turn to heading. It's
Come on.
009 or 5.
Check.
When you lose an engine in a twin-engine aircraft, you need to be able to maintain your climb performance. And you need to be very careful that your airspeed does not decay or reduce too much during that climb.
Okay, engine flame out check.
Check.
Speed and climb rate are dropping fast.
Watch the speed.
Stall. Stall.
The stall warning means the plane is flying too slowly to maintain lift.
Stall. Stall.
The stall warning at low altitudes are a critical situation that no pilot ever wants to end up in.
Flight 235 is less than a mile from the runway. Passengers can now see that they're no longer climbing.
Terrain ahead.
You are low!
The stick shaker is a tactile alerting system where the control column shakes or vibrates very noticeably. It's a very salient cue to pilots to indicate that you must intervene to prevent the aircraft from entering a stall.
The situation is critical.
Well, it's a highly stressful event.
Tower, TransAsia 235.
Mayday. Mayday.
Engine flame out.
Songshan controllers fear the worst. A crash in the middle of the city.
Engine flame out both sides.
How is this possible?
Flight 235 is now only 500 feet above the streets of Taipei.
The crew was surrounded by high-density housing, high-rise apartment blocks, a heavily populated area. You're really between a rock and a hard place.
Impact. Brace for impact.
Oh no! Oh.
Marine, ready.
Oh no!
All controllers can see is that Flight 235 has dropped off the radar. They have no idea if anyone has survived.
Suspend all takeoff and landing operations. Begin emergency procedures.
After hitting an elevated highway in downtown Taipei, TransAsia Flight 235 is sinking in the Keelung River.
I could feel something was off. I thought to myself, why is there water where my shoes are?
Those lucky enough to survive the crash are now at risk of drowning.
I remember very clearly. I saw a woman who I thought was an air hostess. I told her not to be afraid.
The water level starts to rise.
The plane was sinking deeper and deeper. The temperature was very cold. I couldn't hear anything. The water had drowned out all sounds.
Then passengers are relieved to hear a welcome sound. Rescuers are on the way. First responders climb onto the fuselage and start pulling people from the wreckage.
I just wanted the doors to open quickly so that I could escape.
The swift current of the Keelung River means that shocked survivors won't be safe until rescuers can get them to the riverbank. The city of Taipei has never seen an aviation accident like it. Of the 58 people on Flight 235, only 15 make it out alive. All 3 pilots are dead. Investigators from Taiwan's Aviation Safety Council are anxious to start collecting evidence at the scene.
The most important thing for us is to retrieve the black boxes. However, we have to wait for the search and rescue to finish before we can go in.
For now, they have to be patient. But a stunning piece of evidence has already surfaced.
Take a look at this. Just came in. Can you put it up here for me? What was happening on that plane? Play it again.
It was quite extraordinary that the final sequence of events was captured by the dashcam footage in the motor vehicle. It's quite harrowing because you're seeing the final moments of a tragic event unfolding before your eyes.
Freeze it, freeze it.
We were obviously really shocked, wondering why the plane was flying in this way.
What do you think? Left engine? Control surfaces?
When you watch the video clip, we know there's something wrong about the engine. The prop seems very slow.
You can see the propeller blades. They couldn't have been going at full speed.
I thought either the aircraft lost one engine, or either the flap or the aileron jammed during takeoff.
We need to study that wreckage.
Salvage crews pull what remains of Flight 235 from the Keelung River.
We recover everything. I think we finished the wreckage recovery around noontime the second day.
There's no telling which piece of wreckage might hold an important clue. Investigators wonder if the flight control system shows any sign of a malfunction.
So we have to examine that part of the wreckage.
Nothing wrong with this actuator.
We cannot find anything wrong with the actuator, the linkage of the control. We cannot find any normal situation for the flight control system.
Control system seems fine.
A search for any pre-impact failures in the plane's hydraulic system also comes up empty.
Nothing wrong with the hydraulics. Is this the left engine? Yes.
Investigators know from the dashcam video that the plane was banked steeply to the left. A mechanical fault with the left engine seems like the next most obvious suspect.
We need to take a look inside. Get the borescope?
From a borescope examination, we can see whether or not the compressor and turbine are damaged on the inside. Since the turbine rotates with extremely high speed, if it is even slightly damaged, it will be completely destroyed.
But the borescope examination yields no new clues.
The examination showed that everything was in place and all the moving parts were still capable of moving.
Left engine completely operational. Strange.
They need to explore other possibilities.
What about the right engine? Let's go take a look.
They study the right engine. And what they find is mystifying.
Look at the blades. They're feathered.
Feathered is a propeller's fail-safe position. When a propeller engine loses power in flight, the blades automatically rotate parallel to the airstream to reduce drag.
What an auto feather does, it changes the pitch of the blades to reduce the drag on the blades to make sure that the aeroplane's climb performance is not degraded.
The discovery only deepens the mystery.
Why would the right engine be feathered when the dashcam video clearly shows the plane banking to the left?
It doesn't make any sense.
Let's have a look.
When we discover a feather of the propeller, we know there should be something wrong about the engine.
Anything?
Nothing at all.
Both engines yielded normal results after examination. They were both fine.
There's nothing wrong with this engine either.
If both engines were operational, well, why did this plane crash?
Investigators now have two related questions to answer. What caused the right engine's propeller to feather?
Terrain ahead!
And why did the plane bank violently to the left just before impact? At a Songshan Airport hangar, Taiwanese investigators still have no explanation for the crash of TransAsia Flight 235. Video of the turboprop's fatal plunge into the Keelung River has spread worldwide. But clues to what caused the crash are in short supply.
Hello? Okay, thank you. Sir, FDR data's in.
All right, let's have a look.
Investigators hope the plane's flight data recorder can tell them more. The FDR records dozens of performance parameters, including fuel flow, engine temperature, and propeller speed.
Okay, engine flame out check. Check.
Investigators already know that the right side propeller feathered before impact.
Watch the speed.
Let's see the operating systems of engine 2.
Perhaps the flight data can tell them why.
When we go through the data for engine number 2, we find some parameters were normal, like oil pressure, engine temperature, fuel flow.
Engine's completely fine.
But one other piece of data seems to tell a different story.
Take a look at this. The torque is all over the place.
One parameter, the torque value fluctuated.
Torque is a measure of an engine's power to spin the propeller. It increases and decreases during flight, but it's not supposed to fluctuate.
Why is it doing that? Pass me the schematic.
They dig deeper, studying how the Pratt & Whitney engine measures torque.
So we try to find out the design logic for the system.
What's the connection between the torque and the feathered propellers?
They learned that the engine's auto-feathering system includes an electronic torque sensor. It measures how much twisting force the engine is producing. Extremely low torque indicates that the engine has failed, so a low reading triggers the system to feather the propeller. But they know the engine did not fail. There seems to be only one way to explain the unusual torque data.
Maybe the sensor is sending a faulty reading, triggering the auto-feathering unit.
They suspect the problem was not with the engine itself, but with the sensor measuring torque.
We figured out that that probably will be the signal problem between the torque sensor and the receiver.
Send the sensor to the lab so we can analyze it.
If they're right about the torque sensor failing, then they'll finally have solved the mystery of the feathered propeller. But investigators are no closer to understanding another mysterious aspect of this crash. Why did a two-engine plane with a feathered propeller on the right side end up banking to the left? Searching for an answer, they return to the flight data.
What do the parameters of the left engine say? Can you show me the fuel flow, please?
That all seems fine.
Propeller speed?
According to the data, the left engine was in perfect working order.
Engine number 1's performance was always good. All its statistics were normal.
The power lever angle?
But when they check the throttle settings, they make a stunning discovery.
Unbelievable.
When we go through the FDR data, we find that the power of the number 1 engine was gradually being reduced, and eventually be shut off.
The left engine was manually shut down.
Investigators know the ATR-72 is not equipped with an auto-throttle system. The throttles can only be moved by hand.
It had to have been shut down by one of the pilots.
So we start to wondering why the pilot will shut down the good engine.
Honestly, at the beginning, we did not understand how this could happen.
That's crazy. Let's take a look at the circuit board.
Investigators examine the torque sensor from the right engine of TransAsia Flight 235. They're looking for any defect that could have caused the propeller to feather in flight.
The lab used precise testing methods. They made a cross-section of the circuit board and looked at its image.
Take a look at this. It's a broken solder.
They discover microscopic faults in the circuit board.
And that was related to the soldering joints in a particular circuit board being compromised for reasons that were difficult to establish. It was possibly related to some form of manufacturing defect or something of that nature.
And that will be enough to stop the transmission of the signal.
With a broken circuit board, the torque sensor couldn't do its job. Even though the engine was turning, the sensor couldn't detect any torque, so the system automatically feathered the propeller.
The brain of the system thought that torque had reduced below a predetermined value, which I think is about 18%, and that is what triggered the auto feather.
Okay, engine flameout check.
Check.
Finally, they understand why the right side propeller feathered, but they still haven't explained the crash. The ATR-72 has two engines. Losing propeller thrust in one of them should not have been a catastrophic event.
They are designed to fly only with one engine.
Straight ahead. Marine. Pull up.
Pilots train for engine-out operations regularly. Typically, it's bread and butter for an airline pilot to deal with an engine failure on a multi-engine aircraft.
To figure out why 43 people died, investigators must now answer a much more difficult question.
We still have number one engine produce power normally, but for some reason, the pilot decided to shut down the good engine.
Watch the speed.
We have to find out why.
Investigators turn to the cockpit voice recording.
Okay, ready? Let's hear what we got.
Oil pressure? Check.
The accident flight is very short, less than 3 minutes. So we listen to the CVR starting from the takeoff roll to the end of the flight.
Before taxi checklist.
Propeller brake.
Off.
Nose wheel steering.
On. Procedure complete.
Checklist complete. So far, they're following procedure to a T.
You have to make your procedure very clear.
Well, let's see what happens closer to takeoff.
Engine instrument check, normal.
V1.
V1.
Rotate.
TransAsia 235, contact approach, 119.7. Good day.
What's that sound?
Must be the engine 2 fault warning.
When the master warning first activated, they were approximately about 1,200 feet above ground level.
They're flying an ATR-72-600. It shouldn't be a huge problem.
If they follow the procedure, do everything correctly, they should be able to fly back to land without any problem.
This is a crucial moment. Let's hear what they're gonna do next.
I have control.
Investigators hear the sound of the autopilot turning off.
He's disengaging the autopilot. He shouldn't be doing that.
It's hard to understand why the pilot flying disconnected the autopilot during an emergency situation. He just made a difficult situation worse.
Keep playing.
Okay, engine flameout check.
Check.
Their attention will be directed to the engine warning display, which in the ATR-72 clearly indicates which engine has failed.
There's a checklist procedure on the screen. You follow it step by step.
But instead of following the emergency checklist,
Watch the speed.
the captain does something inexplicable.
Pull back number 1.
The captain's starting to shut down engine 1 without fully understanding what the computer system is telling him.
Both engines are capable of producing power, But because the right engine has feathered, it has lost thrust, behaving like a car in neutral gear. When the captain pulls back the left throttle, he leaves himself with no thrust from either engine.
He didn't seem to fully appreciate that that had ultimately resulted in number one engine being shut down.
How could he do such a thing?
Investigators have discovered from the cockpit voice recorder that the captain of Flight 235 shut down the plane's only working engine.
Why didn't the first officer stop him?
They continue listening to the recording, trying to understand why the captain's mistake wasn't corrected in time.
I will pull back on engine 1 throttle.
You can't just say he's gonna shut down the engine.
Pilots are supposed to run a cross-check, where one pilot verifies the actions of the other.
When the pilot flying shut down the operative engine, he did so very quickly without discussing it with the pilot monitoring.
He's acting before even confirming what the emergency is.
When there's a warning come up, the procedure says you identify the problem before you act.
No, wait a second. Cross-check.
The pilot monitoring, to his credit, did try to stop the pilot flying from manipulating the engine number 1 power lever, and he announced he wanted a cross-check, but there was no definitive confirmation from the pilot flying that the problem was engine number 2.
Heading mode.
Instead, the captain interrupts the first officer to ask for a new heading.
We're below 2,500 feet.
Come on.
0.
0905.
The first officer did tell the captain to wait. He knows that the captain was pulling back on the wrong engine. And when he did try to question it, the captain just confirmed what he was doing.
All of a sudden, they've got a dual engine failure, and the pilot monitoring, I think, has been caught off guard, and he's not really sure what's gone on.
Restart the engine.
I can't restart the engine.
Oh well. I shut off the wrong engine.
The pilot flying clearly has an epiphany that they're in very dire trouble.
Restart the engine.
Can't restart the engine.
I shut off the wrong engine.
It's very sad.
When I heard him say, I shut off the wrong engine, I was completely devastated.
By the time the captain realizes his mistake, it's too late.
Impact! Race way back! Oh, no!
Unfortunately, neither crew member actually followed the standard set of procedures for dealing with an engine flame out after takeoff.
Investigators now have an even more puzzling question to answer.
Why didn't the captain understand what he was doing?
The captain's failure to recognize the situation and react properly ended up costing 43 lives. He thought that the left engine had failed, when the aircraft was clearly telling him it was the right engine that had a problem. How could the captain have got things so wrong?
What was this captain's background?
When they dig into the captain's history, they make a disturbing discovery.
The captain failed one of his key training components.
The pilot flying's training records had indicated that he was prone to being a bit anxious.
I have control.
You have control.
Feeling a little bit overwhelmed in emergency situations, and had a tendency to prematurely respond or act in that situation.
Pull back number 1.
He was also fired from his last job.
Although the captain was an accomplished military pilot, his civilian record is raising questions.
Maybe he wasn't used to the ATR 72600.
The record soon confirmed that hunch. Leo Cheon-sung had logged relatively few hours in TransAsia's newest commuter plane.
The captain in the left-hand seat had approximately 5,000 hours total time, and he had about 250 hours on the ATR 72-600.
Wait a second. Throttle! Number 1, feather shut off.
The ATR 72-600 is known for its advanced technology. Investigators now wonder if this aircraft, with its computerized glass cockpit, was too complicated for a relatively inexperienced pilot to manage in a crisis.
Restart the engine. And restart the engine.
They can often be overwhelmed with a huge volume of information. They also have to consider the nature of the automation and the modes that are presented to them. So it's more challenging.
I shut off the wrong engine.
Did information overload lead to the deaths of 43 people in one of Taiwan's worst air disasters? Investigators need to know if the advanced technology designed to help pilots in the ATR 72-600 may instead have contributed to the crash of Flight 235 by confusing the TransAsia captain.
Okay, ready to fly out of Taipei?
Let's do it.
To try to find out, they program a flight simulator using the flight data from the downed plane.
We have weather information, we have FDR data, we have CVR data. So we put those together to duplicate the condition of the accident.
The data lets investigators fly the exact same flight, the same speeds, same climb rate, and 37 seconds into the flight, the same cockpit alarm.
Master warning, engine 2 flame out.
The plane's computer instantly identifies which engine has lost thrust.
Check, autopilot armed, run the checklist.
The automated checklist pops up, clear, concise, and easy to follow.
Up trim on engine 1, auto feather on number 2.
Check.
Engine 2 flame out confirmed.
Confirmed. Secure engine number 2.
The checklist calls for the pilot monitoring to reduce power in the feathered engine to idle. The other pilot guards the working engine.
Then you would bring the condition lever into the fuel shutoff détente, which removes fuel from the engine.
Condition lever to fuel shut off.
Check.
And then the engine will be secured and shut down.
Engine number 2 secured.
Now powered by just one engine, the plane keeps climbing safely on autopilot. The computerized systems have helped the pilots avoid disaster exactly as designed.
It's quite manageable. The crew can continue the flight, climb to a safe altitude, reconsider their options.
Now we just have to fly back to the airport and land. I have an idea. Let's see what happens if we just let the plane fly itself. Reset from the start.
Setting?
When we do the simulator test, we try to find out what will happen if the pilot do nothing.
Incredibly, the simulation shows that even if there had been no pilot input at all, the plane would not have crashed.
The aircraft will continue climb and the fly with no problem. So I think that the aircraft was designed to handle that situation as long as we don't do anything wrong.
Any doubts about the glass cockpit have now been erased. The advanced systems of the ATR 72-600 did not lead to the crash of Flight 235. There must have been some other factor at play. Investigators study reports from previous incidents where similar mistakes were made. They suggest an intriguing possibility.
Interruptions and multitasking.
Investigators know the captain's workload was high. Taking manual control of the plane distracted him from running a cross-check with his first officer.
He's multitasking.
Watch the speed.
He could have been suffering from change blindness.
Change blindness, people are focused or fixated on another item or area of interest, and so they miss what would be considered a very distinguishable change in the environment, but they don't perceive it.
I will pull back engine 1 throttle.
Even when all the systems were telling him it was engine 2, his perception told him he was doing the right thing. Change blindness.
The first officer even tried to warn him.
No, wait a second. Cross-check.
It seems the captain was blind to the clear warning that his right engine had feathered. Investigators finally understand what went wrong aboard TransAsia Flight 235. A microscopic crack in a circuit board disabled an engine sensor that led the system to wrongly determine that the right engine had failed. But that in itself wouldn't have caused the plane to crash.
This was a series of mistakes on the part of the captain. When engine 2 feathered, the captain reacted before he had properly assessed the situation.
The captain should have followed a checklist.
I have control.
Instead, he turned off the autopilot and reduced power in the wrong engine.
I will pull back engine 1 throttle.
All we know for sure is he shut down their only working engine. By the time he realizes, it's too late.
Restart the engine.
I can't restart the engine.
Wow. I shut off the wrong engine.
Why did TransAsia hire this pilot?
Investigators dig into TransAsia's corporate background.
Check this out.
Trying to understand how a pilot with such a poor record ever got through the door.
And this?
This company's been expanding rapidly.
What they find paints a picture of a growing company struggling to compete with bigger players in the competitive Asian market.
A more regional operator like TransAsia Airways appears to have struggled to certainly recruit and retain the sort of expertise that airlines seek.
The crash of Flight 235 would be the last accident for TransAsia Airlines. In November 2016, the company ceased operations and went out of business.
There's a multitude of reasons that the board decided to shut down the airline, but there's an inescapable conclusion that the adverse or poor safety performance of the airline certainly had an economic impact on the airline.
Even though TransAsia Airlines no longer flies, air crash investigators hope that the tragedy of Flight 235 will serve as an important safety reminder to pilots at other airlines around the world.
We all understand that pilots, they're human. Humans make mistakes. So that's why we design the standard operating procedures. And the basic important thing is for people just follow the procedure.